Hello everybody. Welcome back from a lunch that you hopefully enjoyed. As we said before, we are not finished with carbon dioxide removals. We have another session that is following now. There it is about how to commercialize CDR and how to formulate policies and governance structures to support the deployment of CDR. And for the session to moderate, I'm happy to announce Gregor Laumann. Gregor Laumann is Head of Climate Politics, International Affairs Department in the Environment and Sustainability Department of the DLR, which is the German Aerospace Agency. He is responsible for funding priorities in the areas of carbon dioxide removal, and he is also a member of JPI Climate. And to moderate the session, welcome on stage, Gregor Laumann. Over to you.
Yes, thank you, Petra. And welcome, everybody. I'm very honored that I can chair. I was asked to facilitate the last session of today, and clearly we haven't dealt with the topic of CDR exhaustively, otherwise we wouldn't have another 1.5 hours to speak about the topic, with a new focus now, and that is on market development and commercialization. I can hear myself a little bit. Is that how it should be? Okay, that's probably the reason why I hear myself. So the first speaker today is online, I hope so. That is Kati Koponen from Finland. She's senior scientist at the VTT Technical Research Center of Finland. And there she does research on carbon dioxide removal and how it can be permanently removed from the atmosphere. Today, Kati is kicking off this session with a presentation on scenario considerations on the role of CDR and what it could play in carbon neutrality policies in Europe. And she will draw on results from the Horizon 2020 NEGM project. Kati, can you hear us? And
yes, I can. Can you hear me?
Great. Yeah, we can hear.
And can you see my slides? I guess you can see the slides as well. So I will start. Okay, so thank you very much for inviting me to tell you about the results of the NEGM project. It would be great to be there with you, but it will go like this, for this time. And so I'm going to present you the results from NEGM Horizon 2020 project. It took place between 2020 and 2024 and just finished earlier this year in May. And Myles invited me to tell you about our scenarios for Europe that were modeled in the NEGM project. And I will tell you a little bit more widely about the NEGM work and the NEGM findings. And this will be a good background for the discussion then on how to realize this with the market mechanisms and so on. So I will first introduce you the aim of the NEGM project, and then I will focus a little bit on the studies on the environmental constraints for CDR that were made in the project and how those affected our carbon neutrality scenario modeling. And finally go to some NEGM key messages. And as this was a 4 years project, there is, of course, a lot of results available. So please feel free to visit our website. You can find it behind the link here. And here you can also see our excellent consortium where very great people were working together for these results. So the main idea of the NEGM project was to understand what would be the realistic potential for carbon dioxide removal globally and in Europe, when taking into account different constraints by technological, commercial, environmental, and social aspects. So we kind of wanted to filter from the theoretical potential for CDR the realistic potential. And then we wanted to understand how to meet this realistic potential for CDR. So how could the country or EU-wide potentials look like, and what would be the enabling governance frameworks and market mechanisms? And as a part of this study, we also made this type of scenario modeling with times pan-European times model for the Europe. So I will start from the studies on the environmental constraints because they then affected the scenario modeling. So one of the key efforts made in NEGEM was to do a life cycle assessment for several different types of carbon dioxide removal. And our colleagues from ETH Zurich studied over 20 different concepts for carbon dioxide removal, including afforestation, reforestation, biochar, ocean-related methods, BECCS, DACS, and enhanced weathering. And they studied these over several impact categories, so how they would impact the global warming, the human health, ecosystem, and then the fossil resources depletion. And from this table, you can see that none of these methods comes without trade-offs, so we need to understand those trade-offs. And our main conclusion was that to balance the impacts, we will need a portfolio of CDR methods, so that there won't be too much pressure on one impact category by any single method. So this was then taken as a starting point also for the scenario modeling. So we wanted to include as wide a portfolio of CDR methods as possible. Another important part of NEGEM was the study by our colleagues from Potsdam Institute, who studied the BECCS and reforestation potentials outside agricultural areas when taking into account the planetary boundaries. So how would the potentials look like if we don't want to produce any further transgression on planetary boundaries? And they did this with their biosphere model, LBJML. They started from the land areas outside current agricultural land and then started to apply these different planetary boundaries. So freshwater planetary boundary, nitrogen, land system change, biosphere integrity. And as you can see, the area in the map decreases all the time. So they ended up to a situation where almost no potential for BECCS was available when taking into account all these planetary boundaries. And the main conclusion from this was that to enable larger potentials for BECCS and reforestation, we would need global dietary changes to release pastureland for BECCS and reforestation. So this study concerned energy crops. No residual biomass was considered in this modeling. So from this study, we took the limited biomass potentials, and also in our scenario modeling, we then assumed some dietary changes that would need to happen to enable larger potentials. For this European scenario modeling, we aimed for carbon neutrality in Europe for 2050, including then this portfolio of CDR solutions. We studied 3 different storylines, one focusing on optimistic technological development, one focusing on strict environmental constraints, so strict respect of planetary boundaries. And here we had limited BECCS potential and emphasis on reforestation for restoring ecosystems, and we assumed some dietary changes. And then because of the current political situation, we also studied this security focusing scenario where we, for example, limited the CO2 storage capacity. We studied 2 cases for Europe with the full portfolio of the CDR methods and also with a limited portfolio to see the effects. So in the full portfolio, we included BECCS, DACS, biochar, and reforestation, enhanced weathering, and soil carbon sequestration. And in the limited portfolio, we included all the others except enhanced weathering and soil carbon sequestration. For the model, we used a pan-European times VTT model, which is a technology-rich partial equilibrium model doing cost optimization for selecting the technologies to be used. And the study was for EU 31 region, and we applied the current EU policies for climate from the EU 55 Fit for 55 package and from the effort sharing regulation, and we set a net zero target by 2050. And the ETS prices, for example, were taken from the European Commission with additional measures scenarios. I first want to mention some limitations of the study. So as this is a cost optimization study, it should not be interpreted as a forecast of CDR potential, but this can be the basis for the discussion, and it provides a rough understanding on the scale of CDR that could be needed in future. Our model only includes CO2 emissions, so no methane or nitrous oxides emissions are included or other greenhouse gases. And also the LULUCF sector is not included. So this could lead also to overestimation of the demand for CDR. And of course, there are several uncertainties related to the technical parameters, the cost development, the country-specific potentials, and so on. But here, anyway, you can see the results. So these are the CO2 carbon dioxide balances for EU 31, and in each scenario, the carbon neutrality is reached at 2050. So the first thing you see is that the emissions still remain quite high. So that was one of the challenges in our modeling. And the conclusion would be that the conclusion is that more ambitious policies for emission reductions are needed. The current policy measures are not sufficient for deep emission reductions. A key finding was that a wide variety of these CDR options appear to become cost effective, and that then they merit consideration in all the countries. And also all the European countries started to use some kind of CDR solutions. And in our results, around 1 gigaton of CDR by 2050 is needed depending on the scenario. One important finding was also regarding the BECCS technologies. So traditionally, BECCS is done with bioenergy crops for bioelectricity production. But in this study, the residual biomass was used, and BECCS also appeared in addition to power plants in combined heat and power production plants, in biorefineries, in industrial plants with biogenic CO2 emissions, such as pulp and paper industry plants. And beyond 2050, DAX appears to become dominant, but it is already important in 2040. And in these scenarios where we had a limited portfolio, then DAX becomes even more important towards the end of the modeling period. So that was about the scenarios, but then in NEGAM we did many things, and a very important aspect were the stakeholder and citizen perception studies as well. And I wanted to show you one finding from the latest stakeholder survey, and the finding was that the stakeholders considered that the permanence of the CO2 capture is really the key dimension, even more important than the cost of removals. So this is something also to keep in mind. And finally, some NEGAM key conclusions. So as said, the existing climate policy measures are not sufficient for deep enough emission reductions. So we need more emission reduction measures to avoid over-reliance on CDR. But At the same time, we also need incentives and market mechanisms for CDR so that we can reach the scale needed in the coming decades. So the NEGEM key conclusion was to set realistic, separate, and legally binding targets and policies for emission reductions, permanent CO2 removals with geological storage, and for LULUCF sector and carbon farming. It's also important to recognize the different roles and co-benefits of various CDR methods. So the CO2 storage time and permanence is essential, and we need permanent removals for sustainable net zero. But at the same time, for example, reforestation can significantly contribute to reaching international targets for nature restoration. And in Europe, we need to adopt member state-specific CDR portfolios, which consider the individual countries' characteristics. And further studies are needed to understand the realistic potential in each European country. So thank you very much for your attention, and I'm happy to answer if there are any questions.
Yes, thank you, Kati, and I hope you heard the applause. Thank you for this comprehensive presentation on the results of the NEGEM project. So I do think before we then go on and go a little bit deeper into this question of market mechanisms and commercialization and the results from the NEGEM project, which is then going to be presented by Myles Allen, we can take a question or two directly on this presentation of Kati, if there is one. In this case, Kati, I have a nice green dice with a microphone, which I may throw around. I don't know whether you see that, but there is one question from...
Yeah, can you elaborate a bit more why the LULUCF was not included in the portfolios in the analysis?
So it was not included in our pan-European times model, which is more like an energy system model. But of course, in the project, we, as presented, we had this land use modeling in different with the different models. So this LBJML model. So we used then the results from that model in our study, but for the biomass resources and for the reforestation potential, and also for the biochar potential. But the LULUCF sector, so the LULUCF sink and emissions are not included in that model. So that's the reason.
Thank you. If there is no other direct question this time, so thanks again, Kati. I guess you're still on board for the rest of the session, I hope. And I will then welcome Myles Allen on the stage. He's Professor of Geosystem Science at University of Oxford. I mean, we've still, yeah, we all know you. You have been introduced, so I can be short on that part. And you are going to present results on the NEGEM project's work on market mechanisms, commercialization.
Yes. And don't worry, there's no equations this afternoon. In fact, it's quite the opposite. It's the last session here. So I wanted to talk about. Frank asked me to talk about commercialization models for carbon dioxide removal. I want to give you some really high-level things to think about. Is this what we should be thinking about? I know Steve likes us to think about this because he's like the king of carbon dioxide removal, but should we be talking about? It's not working. It's working. Drum roll. Nope. Almost. Okay. This computer. Right. Okay. Anyway, we're good. Should we be talking about commercialization models for carbon dioxide disposal? The reason I like to talk about carbon dioxide disposal is it links the requirement to dispose with the fact that you've generated in the first place. I worry that carbon dioxide removal sounds less like something that one does without any obvious connection to the reason you have to do it. Okay, so anyway, just something to think about. Or to put it even more bluntly, how to pay for carbon management. I was recently in North America, and nobody talks about carbon dioxide disposal there. They talk about carbon management, just as we don't talk about urban waste disposal. We talk about waste management. It makes people feel better. Anyway, okay. Just to give you a flavor of why it's important to think of carbon dioxide removal in the context of carbon management and carbon dioxide disposal, these are the technology neutral scenarios in the C1 scenarios in AR6. And what I'm showing you is the amount of carbon dioxide we still produce in red, the amount that goes back underground, either point source capture or BECCS or DACS. Most of that by the end of the century is BECCS and DACS, but sort of by mid-century, more than half of it is just point source CCS. And then the balance of those is the black line, and the contribution from LULUCF, from transition from deforestation emissions to nature-based solutions taking carbon dioxide back out of the system is in green. So the first thing you notice, of course, is we burn less and we store more. That's the big balance. That's the sort of simple balance over the century. The contribution from the green line is quite small and dominated by that passive sink problem that I was talking about earlier, so we may not even be able to quantify it at a global scale. So I think we need to have a much more focused conversation about how we balance red and blue, accepting that we need to restore the biosphere, and for all the reasons I was talking about this morning. That's where we need to aim for. Geological net zero is a balance between remaining production of carbon dioxide from geological sources with carbon dioxide committed to geological sinks. In the scenarios, we reach geological net zero a few years after we reach net zero. So the removal by the biosphere buys us 5 years or so, but basically it's geological net zero that we ultimately need to be aiming for. And the accounting for geological net zero is very simple compared to the accounting for the biosphere, because there are no natural processes that put carbon back into the geosphere, into the solid earth, and there's really no natural, I mean, not significant ones before somebody complains, and there's no natural process that releases carbon dioxide. It's burning fossil fuels and making cement that releases carbon. So the accounting is very straightforward. If you think about the geosphere, when you think about the biosphere and the oceans, the accounting becomes really complicated, but the geosphere is fortunately nice and simple. So right now we put back into the ground about 0.1% of the CO2 we generate from burning fossil fuels and making cement. And achieving geological net zero means getting that fraction to 100%. It's very simple. So again, you can see from this figure, and this is why the sort of commercialization pathways discussion is so important, geological disposal is, in terms of tons of CO2, it's about 30% of the solution. So in these scenarios, we avoid generating between 2 and 3 or maybe 4, I don't know how much CO2 we would generate without climate policy. So the top of this red wedge is kind of fuzzy. But whatever it is, we reduce the amount of CO2 we produce by a lot. So we avoid producing 2 to 3 trillion tons of carbon dioxide cumulatively by 2100, but we put 1 trillion tons back underground by the end of the century. These are these are scenarios where we get close to 1.5 degrees. So it's, and by the way, I'm saying 30% of the solution by mass. It's probably more than 30% of the solution by money, because it's more expensive typically to put CO2 back underground than it is to avoid generating it. That's kind of the problem, if you like, for actually getting going on this. So it's 30% by one measure. It's receiving less than 1% of transition investment right now. So this is from Bloomberg New Energy Finance, the money we're spending on the energy transition. And all of those I've highlighted here are only relevant to reducing the amount of CO2 we produce. And only 2 of them, so things like power grids or renewable energy or nuclear, this replaces fossil fuels. This reduces the amount of fossil origin carbon dioxide we produce. Only 2 of them, hydrogen and CCS, are relevant to increasing the amount of carbon dioxide we store geologically. and they're less than 1% of the investment. So it's a big part of the solution, a tiny, tiny part of the investment at the moment. Why is that? Well, because there's no case for it. There's no immediate incentive. And the problem is, I think, largely has arisen by the fact that we're highly reliant on carbon pricing to actually motivate to motivate climate mitigation. And the way it's supposed to work is that you introduce something like $100 per ton price for CO2. This is somebody's, it's actually from Goldman Sachs, but I mean, the picture is pretty similar. Because it's Goldman Sachs, it's a nice, pretty cost curve, but other cost curves are available. But what this is telling you is these are, as you move across to the right, this is telling you the cost of reducing emissions by reducing the amount of CO2 we produce. That's what's interesting about this curve, is it's only including measures that avoid producing CO2. And you can see there's a lot of things we can do for less than $100 a ton. Famously, the AR6 concluded for less than $100 a ton, we can halve global emissions. So that's almost entirely through avoiding producing CO2 in the first place. The big orange bar in the middle there is we're going to be replacing fossil origin power with renewable power, for example. But the question is, how high will carbon prices need to go? You'll notice over on the right there, there's a sort of shadowy gray region, which they tactfully call non-abatable at current conservation technologies. Those are activities that, according to the people who produced this curve, there just was no obvious alternative to generating CO2. These are things like cement production, aviation, these hard to abate. We were talking about hard to abate. These are what people like to call hard to abate sectors. And if we look at carbon prices in these scenarios, they go pretty high. This is slightly out of date. This was from 1.5 degree report scenarios, but the message is pretty similar in the more up-to-date ones. The light blue ones are the 1.5 degree scenarios. Notice it's a logarithmic scale in the vertical, okay? And you'll notice that many of these, by the way, you'll notice that they're straight lines. We can talk about that, why they're straight lines, because that's just the way these scenarios work. But they're going to prices in the region of $100 to $1,000. They go above $100 a ton very quickly, and then go up towards $1,000, even $10,000 per ton by the end of the century. And in fact, if we just plot those scenarios all together on a single plot, plotting the 2050 carbon price in the horizontal against emissions in 2050 in the vertical, you see there's actually quite a clear pattern. It doesn't matter which SSP you choose and which level of climate ambition you choose, they all point to the same result, which is something like €1,000 per ton of CO2 to get you to net zero. Now that's kind of a weird result, because €1,000 per ton of CO2 is actually higher than the cost of BECCS in these scenarios. So why do the models predict that we actually need a carbon price higher than the cost of capturing CO2 out of the atmosphere and putting it back underground in order to get to net zero? So we were very puzzled by this. We delved into the scenarios, and the reason is because the scenarios assume, probably correctly, that we don't build the capacity fast enough for carbon dioxide, for geological carbon dioxide storage. And if you don't have the capacity to store CO2, the only way to get rid of, the only way to avoid putting it in the atmosphere is to close down the activity which generates it, which is the really expensive mitigation measure. So that's it. The integrated assessment models assume that carbon dioxide storage capacity is primarily limited by deployment constraints over the next 25 years. Which is why, of course, this is so dangerous. And I gather this is going on in Germany at the moment as well. The environmental movement is fighting against the deployment of geological CO2 storage. Okay, so that guarantees we will end up with those €1,000 a ton. If we don't build it and start building it now, it guarantees we end up with those €1,000 a ton carbon prices by mid-century. And for me, €1,000 a ton carbon price is equivalent to policy failure. Nobody's going to pay it. They'll just bend the policy. This is a UK example, but it's the UK, so who cares? So this is where we need to bring the net into net zero. Okay, so that's the red line here is the one I showed you before, showing the cost of measures to reduce the amount of CO2 we produce. And the blue line is the cost of measures to increase the amount of CO2 we store. Okay? It combines both biological storage and geological storage, but I'll separate them out in a minute. So the point is, we can eliminate 75% of our emissions without any use of geological storage. So one way of thinking about it, if you wait for the carbon price, you would wait until the 2040s before you start thinking about putting CO2 back underground. But then it's too late. And then you get the result that you hit the wall, you hit that hard to abate part, carbon price goes through the roof, and your policy falls over. And maybe we're even seeing sort of inklings of that already with the backlash going on in Europe at the moment. These are the technologies we're talking about. At the left-hand end, there's the natural sinks, although some not very natural things like natural gas processing CCS. But in the middle, there's sort of industrial CCUS. So the U is misplaced here. It should be basically industrial carbon capture and storage. So capturing CO2 from point sources and putting it back underground. And over on the right, the big blue wedge is direct air capture and storage, which is highly uncertain what the cost is, somewhere in the range of $150 to $400 per ton. So the question is how to pay for it. Am I 5 more minutes? 2 more minutes? 3 more minutes?
You're an academic.
No, I know, that's the danger. I think, yeah. Yeah, okay. So at the moment, business models for geological CO2 storage depend either on direct subsidy, which is 45Q in the US, or these sort of SDE++ in the Netherlands, the Swedish reverse auction, 22 billion something in the UK. We're not quite sure what it is, but it's there, apparently. These are very inefficient at driving down costs because basically the government is offering to pay money for CO2 storage, so the industry is accepting the money happily, but it's not clear that it's a good way of making it cheap. And it's politically vulnerable. I mean, this hasn't appeared yet, but it will. Essentially, the US taxpayer is being asked to give a lot of money to oil and gas companies to put CO2 back underground. And at some point, the US taxpayer is going to say, wait a minute. And we've seen so far that carbon pricing has been ineffective because this is a technology with very high unit costs and very long development times. It takes a decade to prove a geological store and so on. That waiting for the carbon price to rise high enough to motivate people to do this hasn't worked so far and probably won't in time. The new element here, which we are very excited about, appeared in the course of the NEGEM project. And in fact, I think, not myself, but I think some of the NEGEM partners, notably our partners based in Brussels, may have had something to do with the wisdom of the European Commission was the only thing that mattered behind the Net Zero Industry Act. But it introduces a really interesting new development here. Article 18, which I believe is now Article 23, introduces a mandate on fossil fuel producers to provide 50 million tons of CO2 per year geological storage capacity in 2030. And crucially, contributions are calculated pro rata on the basis of each entity, that's an oil and gas company, each entity's share in the union's crude oil and natural gas production from January 2020 to December 2023. So this is a whole new business model for carbon dioxide disposal. It's not carbon dioxide removal yet, but it's providing that geological storage, crucial geological storage capacity that will be needed for geological. And I think we can take some inspiration from this in thinking about business models for carbon dioxide disposal going forward, for carbon dioxide removal going forward. The genius of the Net Zero Industry Act is it follows, for the first time, climate policy is following the Willie-Sutton principle. Does anybody know what the Willie-Sutton principle is? He looks like a nice, friendly guy wearing a tie there, but he was actually a bank robber, and he robbed banks because that's where the money is. And if you stop and think about it, the Net Zero Industry Act has finally hit on the Willie-Sutton principle in climate policy. Hit them where the money is. The money's made when fossil fuels come out of the ground, not at the point where they're burned. Typically, these hard-to-abate sectors, like cement plants or steel plants, have very small margins. And that's why reserving expensive mitigation technologies for industries with very small margins is potentially dangerous, because those industries just give up and go to China or somewhere without, and then you have to talk about CBAMs and so on. Okay, just to give you a context of this, aggregate fossil fuel taxes and rents in 2022 exceeded $150 per ton of CO2 generated. Now, 2022 was an exceptional year, of course, okay? But wait a minute, $152 per ton of CO2 is enough to dispose of all the CO2 that it generated. If half of that was point source capture, half of it free air capture, that's pretty. So we could have solved the problem in 2022. Of course, the money went somewhere else. Mostly went to fuel the war in Ukraine and that sort of thing. But, you know, that's where the money is. That's why the Net Zero Industry Act is such a game changer. Because finally, we're tapping into the part of the fossil fuel value chain where the resources exist to solve the problem. So this is the question I'd like to sort of leave you thinking about, how we can extend the Net Zero Industry Act principle, this idea of obligations on the people who are benefiting from continued use of fossil fuels to go beyond just storage capacity in 2030, which is just sort of an initial, current issue that the European Union wanted solved, towards actually getting us to net zero. And I'm not going to do this exercise because it'll take too long. Sorry about this. I'll just cut through to the, sorry, because I've run over time. But just to remind you, the cost here, so, you know, if carbon dioxide disposal costs, you know, $50 per ton of CO2 at point sources, going up to $250 per ton, you know, then, and if you sort of increase the amount of geological stored carbon you need smoothly over time, that's what the cost of the policy looks like to the consumer. Eventually it goes up to $250 per ton, but it starts really low because you're only sort of requiring a small obligation. And in the context of recent natural gas price fluctuations in Europe, that's solvable. You can see the little blue arrow there in the corner? That's the cost of free air capture. That's where the money is. Remember Willie Sutton? That's what it looks like over 30 years compared to petrol prices in the US, Canada, and the UK. Okay, so you can see it's about what petrol prices have done over them. So we could ramp in mandatory carbon dioxide disposal on all fossil fuel use, and it would have the same impact on petrol prices as they've gone up in the past 30 years. Remember, we need to stop fossil fuels from causing global warming before the world stops using fossil fuels. I don't know if anybody in the room knows what this picture is, but it is about this problem of, okay, I'll tell you. It's a village in Greece where they discovered the village was built on lignite. And this is what happened, okay? And this is why we need to stop fossil fuels from causing global warming before the world stops using fossil fuels. They left the church, they dug out the ground underneath the houses, but they left the church, which tells you that the only carbon price that will stop people using fossil fuels forever is the threat of eternal damnation. Okay, so that's what we need to sum up. We need credible CO2 disposal plans applying to all emissions, including Scope 3. 10% by 2035 would be great, 100% by the 2050s. Okay, so that's a sort of idea of a very different commercialization pathway for CDR that I hope will give you some things to think about.
Thank you. Thank you very much for solving the problem in this enjoyable manner. But we perhaps...
I'm sorry, but we had to skate over that.
So I would now like to invite Felix Schenuit to join us here on the panel. We have Joanna Arlinghaus on the program, but she called in and she's ill today, so she's not going to be with us. But please join us on the panel. We're going to sit here and perhaps start the discussion. Felix is associate at the German Institute for International Security Affairs, and he's working on especially the international dimension and cooperation dimension also of development strategies around perhaps also commercialization. And Felix, if I was an investor and I listened to all of that, and I imagined I was a company which was asked to join the market and enter a market where everybody tells me this market is transient. the rules are totally unclear. All mechanisms in place are virtually under-resourced, or they are not suited to cover the risks I'm going to take. And well, everything is developing very slow. Why on earth should I join this market? And perhaps, I mean, you're working a lot on carbon dioxide removal, on carbon management, also the international context. Can you tell us a little bit about like history in the making? What is happening on the national level, on the EU level, and how does that tap also into perhaps an international collaborative framework, enabling framework that perhaps tries to ensure also a transparent and fair set of rules for this market?
Yeah, thanks. How much time do I have for these questions? No. So after your presentation,
well, you have a point of reference.
Yeah. After your presentation, I can't make sense of my notes anymore because I was like making notes in the meantime. But so to your question, I think when we talk about carbon dioxide removal and especially carbon dioxide removal policy, there are strong assumptions about carbon pricing that we don't usually talk about. You mentioned it that the carbon price should work, or that we assume that it works at some point. But if we look at CDR policy on the ground, and that's what we did in the State of CDR report in the policy chapter, for example, but also in several other papers, it's of course, well, in papers we then call it fragmented, but it's of course very messy. And countries differ a lot in how they tackle CDR. So there is not this one market at this point. So it really depends on what country do you look at. And countries not only differ then in the instruments they choose, they also differ in the way they address carbon dioxide removal as a technology, because sometimes they really, and you mentioned that already, they tackle carbon management, and then we don't specifically talk about carbon dioxide removal. And I think that we as a CDR community, we have several research projects. We don't really manage to address this gap between, or this link between carbon dioxide removal and carbon management, but we really see it in policy making. So I think there is actually our research also a bit fragmented. We have the CCS and CCU community, and well, these are two communities as well. And then we have the CDR community. And I think we really have to talk about how we bring these together because, and linking it to the market again, there is, of course, also some sequencing, because when we think about very expensive direct air capture, maybe we can use it as for producing syn fuels in the short term, and then in the long term for direct air capture and storage. But if I would present it in Germany like that, you mentioned Germany and the problems with CCS, they would say, well, but this is then a secondary or a new lock-in, because then the people would only sell e-fuels and not do the storage part in the end. So I think it is politically very challenging to actually deliver CDR in the long term. I prepared a little bit on the European Union and what's going on just ahead of the new legislative cycle. We can talk about it later, but maybe not now. Just one remark on the fair share. We recently had a very brief comment on the G7 as a relevant actor, because they describe themselves as industrialized democracies. They have a high share of historic emissions. And there really is the expectations of some countries that these countries take the lead on carbon dioxide removal. And I think the G7 could actually be a relevant forum for that. They could agree on joint procurement pledges, for example, to create demand for carbon dioxide removal. Or they could also agree on a joint net negative pledge, talking about the second half of the century, talking about net negative emission. I think that really is an important discussion that we should have to enable the discussion about how we get to a market for carbon dioxide removal. Maybe I stop here and
Yes, maybe perhaps before we throw the floor open, I have one question, and that links actually to what Maria Sanz was asking just a minute ago and also presenting yesterday. I think you had a very comprehensive presentation on the land sector. And it shows, amongst other things, how messy this sector is already without any CDR coming on top and any further conflicts, which are already there in abundance around scarce land resources. And so what on earth makes us believe that exactly this sector would then be saving us in a way by contributing in abundance through free markets CDR, and or perhaps on the contrary, and that was another thought I had when listening to many of the presentations, can that also in an international context? G7 is one level, but if we expand it to G20, or if we expand it to our friends from Guyana, I think we had this, this example a couple of times during the past days. So can it also be a game changer in sustainable land use? Because it might be providing, if in a framework that is equitable, that is fair, that is transparent, it might provide people from Guyana with another perspective of earning money in the future, with reliable income perspectives, and that's not cutting the trees because they rely on mining or have to resort to mining. So just perhaps open and provocative question. The question I have is, because you spared us the European part, we have a lot of European discussion going on right now. We know that neither UK nor Germany nor any of the countries going to resolve the land problem within its own borders, and so is Europe, I think, even though we have Norway included there. So perhaps we can expand a little bit on that, and then we throw it open to the floor.
I'm trying to understand what's at the heart of the question, and I think, but maybe that's my bias of how I understood the question, but do we want international credits to play a role in European climate policy, right? Isn't that the question then? Do we?
In a way it is, yeah. Isn't it that an international question we are asking? And isn't it an international market automatically we're talking about?
Yeah, and I think to me, that's, CCS was really a toxic issue in Germany for the past 15 years. And I feel like international credits is something similar to that in Brussels right now. So if you raise the question, people usually raise the eyebrow, oh, I don't want to talk about international credits, we don't really want them. We had them in the ETS once, we don't want to do it again, it was a bad experience. So I think it really is a very difficult topic. We now see former European Commission officials writing papers about how it could maybe be reintegrated into European climate policy. So I think the debate really is coming, and it's better that we have it now rather than being at a point in the mid-2030s where we realize, oh, it's very, very hard to achieve our climate targets, and then we rush international credits into climate policy. So I think that is it's better to have the discussion now, but I'm sure you...
I mean, my feeling is that the jurisdictional division or even the sort of disaggregation into emission reductions and removals is less important than the biological-geological divide. And if we were to establish the principle that if you want to compensate for geological origin CO2, you've got to store CO2 back in the geosphere, then international credits become relatively harmless in the sense if we're, provided it's verified, if we're paying Saudi Arabia to capture and store CO2 under Saudi Arabia, I think that's not going to be cheap, but I don't see a particular problem with that from the point of view of the climate. But if we allow international credits the way they are at the moment, where Europe starts paying Guyana to not cut down Guyana's forest and to take credit for Guyana's passive sink, then that's a real problem, because then we're sort of redefining net zero, as I was pointing out this morning. So the problem is not international credits per se. The problem is the fact these credits mix biological and geological carbon and pretend that they're somehow exchangeable, and they're not. And so that's the separation we need to make.
Yeah, thank you. I invite you to ask your questions, and I would also explicitly encourage the people in the virtual space to send in their questions via the chat function, and then we have one gentleman here who is then alerting me if there is a question from the ground. So I have two questions over here, but I stop here, otherwise I can't throw the dice.
Looking to me all the time, so I guess. Well, I think the first problem was exactly that one, to try to mix biological with emission reductions from other sectors. And we knew that, but we were apparently desperate at that time, so we're more desperate now. It's a risk. But I think at least the use of biological credits should be restricted to the actual domestic, rather than expanding beyond the boundaries of the governmental regulations. At least, I mean, this will be the minimum that I will allow if I will be a dictatorship. But I concur with Myles that we cannot pay with carbon credits the protection of forests or global forests, which is the major thing we have at the moment. And that was a big debate with the RED discussions. Because, of course, the countries were saying, yeah, but I did good because I protected my forest. And these guys are going to be paid because they destroyed their forest and now they're going to reduce their emissions. And that was a fair argument. But the solution wasn't to include everything into the same pot. And that was the first mistake. So I think we have to correct that. And I believe that I concur that geological storage is, for me, a much better solution. I think the carbon is one of the services that biological systems can provide, but is not the only one. And there are much more important ones. At the moment, water is a big issue, and we are not paying enough attention to that. And sometimes the mitigation proposals we have to capture carbon in biological systems are against what can be provided on preserving the water cycle, for example. So I think we have to rethink what is the role of biological systems in the sustainability we want to build around. And it's not only about the climate change. That's, I think, the major concern.
Thank you. I think that was more of a comment than a question. So perhaps
It was an answer.
it was an answer. It was actually providing an answer rather than a question. Steve.
Great. I can't believe you called me the king of CDR, Myles. That was so embarrassing.
You are.
No, I'm not. No, I'm not.
Crown Prince, all right.
That, and I never had it in the first place. No, I really like the carbon take-back obligation idea. We've discussed it many times, Myles. It's conceptually neat, and I'm delighted that, you know, maybe through the Net Zero Industry Act or through other jurisdictions it might get tried. I guess I'm sort of philosophically a bit of more of a policy relativist in that I think lots of countries are used to different policy approaches, and it's almost good if we try different things that are suited to different jurisdictions. And so specifically for countries or jurisdictions that might want or need to go net negative as part of a global net zero or going beyond, I was wondering if you could unpack how this kind of policy approach might play out, whether both of you could, because I can see how getting to net zero, when you eventually get to the end of fossil fuels or get that bit to net zero, you're balancing your extraction of fossil fuels with your flux back into geological stores. But if you look at these pathways to get to net zero or beyond, you're often, well, a lot of countries have net zero greenhouse gas targets, not just CO2. And a lot of the residual emissions are no longer in the fossil fuel sector. Okay, you've got aviation kerosene, but you've got land, you've got industrial processes, non-CO2 greenhouse gases in the mix. And then if you want to go net negative, which I think, you know, the EU has an intention to do that beyond climate neutrality. What's the role of the fossil fuel companies there? Are you asking them to sequester more than 100%? And by that point, they will be a lot smaller, and their revenues will probably be a lot smaller as well. So what happens beyond net zero?
Well, the short answer is, of course. I mean, let them sweat. And if they die faster, well, then that's just the way it goes. I mean, isn't that what everybody wants? I mean, the point is, I would argue you want to make sure that those who benefit from using fossil fuels, which is the industry and its customers, pay for carbon dioxide disposal for as long as possible. Because the only other entity in the world that could pay for it is the taxpayer. And that's not fair, because that means everybody, including the people who don't use fossil fuels, end up paying to clean up the mess caused by the ones that do. So as long as possible, the industry and its customers should be paying for this. And only when the industry is dead and nobody's using fossil fuels anymore, anywhere in the world, that's the time to say, okay, fine, now the taxpayer joins in. But for some reason, we're doing it the opposite way around. I don't know how they do it. Anybody would think they might have good lobbyists.
Once again, I think I can only make it more complicated. I could just say that the European Union is not set to have its climate policy is not net zero aligned at this point. If you look at the ETS, for example, last allowance being issued in 2039, no real plan what happens to emissions that will still be emitted in the emission trading system. So we don't know what happens to our instruments at net zero, and there is no plan for net negative. So being stuck a little bit in the current CDR, climate policy, I have no idea how it could actually work. I've been involved a little bit in the work on a carbon central bank, that may be an idea to transform the ETS into something that could also target net negative emissions. But I feel like this discussion really is at the very, very beginning. So I don't know. And to the point on residual emissions not coming from fossil fuel sectors or producers, well, if agriculture is the main sector that emits emissions in 2050 or after 2050, do we really want to make the agriculture sector pay for removals? I mean, if we still would apply polluter pay principle, I feel like that's another political struggle we would see in Brussels with blocked streets. I don't know. So I think it's difficult to continue the polluter pay principle after 2050, maybe. So that's the key conceptual question. But I don't have an answer on how to solve it.
Perhaps, if I may, I know you're also following the national strategic development, for example, in Germany, of the national negative emissions strategy. Do you feel that this polluter pays principle is resonating in the deliberation somehow? Is it?
Oh, that's a very good question. So first of all, I think this process is really a very good idea because it aims at also talking about 2060, and it's one of the very few countries that addresses explicitly what happens after 2050. We will have to see whether they come up with a number or what, maybe like Denmark, they already have a target for 2060 or after net zero. So it's good that we see this, but the question of whether they still think of it as a polluter pays principle after 2045, it is in Germany too early to say that, but my feeling is they have in mind a discussion that sets up a long-term market for carbon dioxide removal and not just a short-term incentive, which I think is a good thing. Shouldn't be the only thing. We should also talk about short-term incentives maybe, but yeah.
But I hope the conversation is about who's the buyer in that market. Because at the moment, far too many policymakers think the only possible buyer is the state. And if you look, for example, at the UK, the cost of our carbon dioxide removal program in 2050 will be £350 million a week. Those who've lived through 2016 in the UK will remember that number. And I'm sure, the benefits of that carbon dioxide removal program will be considerably less than the obvious benefits of membership of the European Union. And I can see the bus already. And that is a problem. If the taxpayer is paying for this, it's going to be very vulnerable. So that's why we need to think about, if we're talking about how do we pay for this, it can't be the taxpayer. It's just too easy then for a populist government to get elected and shut it down. And lots of free money.
We have another question over here.
Yeah, thanks, Myles. And a slightly bus-related question. Just on the Industrial Act, does that place the obligation on the suppliers or the producers? Because if it's the producers in the EU, we don't really have a lot of, or does it apply to the extent to the UK and Norway?
I'm hesitant to say this in Brussels, but oddly, it only applies to producers. So the actual number of obligated entities in the European Union is very small, but the actual obligated requirement is very small as well. I mean, it's only to provide 50 million tons of CO2 storage capacity. So it doesn't include the cost of the capture and so on as well. So there was a move to include importers as well, which to my mind would have made much more sense, because then it would have been economy-wide, level playing field and all the rest of it. For reasons I don't understand, that was not included. But one particular importer that doesn't produce in the UK apparently was vehemently opposed to the inclusion of that, and their name was ExxonMobil. I couldn't possibly comment whether that had any impact on the decision. But anyway, importers were not included.
It's a pity, right? Because I would imagine looking at production profiles.
It's early days. It's not all over. Maybe we can,
Yeah, but they might be gone by 2030. The one looking at the production
ExxonMobil?
profiles.
In your dreams.
Oh, no, the EU. Sorry, no, the EU indigenous suppliers looking at their production profiles at the moment. Well, what'll be left in 2030, but it needs to be extended. But I agree, it's a small victory.
Yeah, we need to know what happens after 2030, and we absolutely need to think about importers as well as domestic producers. It doesn't make sense to only include domestic producers.
Felix, would you like to add?
Maybe just to provoke a little bit, because I think the symbol of getting companies involved in this obligation, it is very important, but I think more important the more important element of the Net Zero Industry Act is that member states are obliged to actually report on their storage capacity every year and on the progress of CCS projects. And I think the material that we gather there is more important for future CCS projects than the symbol of the, which I really like the mechanism, because it's easy for me, again, if we talk about CCS in Germany, this is an instrument that is easily to explain because it's not the public that pays for CCS in this context.
I mean, of course, eventually the public pays for everything. But the point is, I mean, you know, but the point is, it is actually, you know, any economist will tell you that the further upstream you impose an obligation, the more efficient the allocation of resources. So if you, so that ultimately the best place to impose an obligation like this is as the fossil fuels come out of the ground. And then, you know, you fix the problem at source, and then the cost of fixing the problem sort of propagates through the entire economy.
Yeah.
Hi, Per Anke Nielsen from the Confederation of Norwegian Enterprise. I have a comment and then I have a question. And I can start with maybe saying something. I just wrote up my Confederation's reply of a hearing that the Norwegian government has on Net Zero Industry Act. And our advice was to join the EU. I mean, we are not a member, but we are a member of the single market. And in order to be a member of the single market, we have to be part of that, not 50 million tons probably then, but, you know. And our take towards the government is that, of course, this is a business possibility for Norway. Because one thing is to have the storage capacity ready for you. The question is, who is going to pay for the capturing and the transport? Because that's, you know, where the costs really are. But that, I guess that's another discussion. But my question was really, don't you think when we now have a carbon price, well, it's a bit down now, but you know, it was touching 100 euros. And I know that this cement plant in Norway that is actually starting to capture as we speak, that they will of course have never revealed to me what the costs are, but my guess is about 80. So don't you think that if you see a cost going, you know, 100, 120, and mind you, you know, there's no more quotas to be given out from from 2034. So the cost will then, well, soon skyrocket. And don't you think then a lot of these companies will actually start capturing and delivering this for transportation out to, you know, Norwegian storage facilities? That's my question. Thank you.
Well, I'm sure you've got.
Who wants to start?
I think, well, that's the idea, right? That how it should work. But if we look at cost projections, I don't know. I often see it really depends on what kind of capturing process. As far as I'm not an engineer, but I think for many capturing processes, it will remain expensive for quite some time. And you know, when we have a carbon price of 200 euros, I think we will have other problems with the ETS than too much CCS. I think it will be really hard to, like, you know, I think it will not be anytime soon that we will hit 200 euros for the ETS, I think, and covering everything, transport, MRV, and storing. But maybe you have other knowledge about the...
I mean, there's the sort of practical experience we have. You know, empirically, carbon prices, particularly the volatile carbon prices you get with an ETS, have not incentivized carbon capture and storage, and they've certainly not incentivized carbon dioxide removal to geological storage. So there is a hope that things will change as the carbon prices rise. I know that lots of people have that hope. I think it's quite a risk to just rely on that. So that's one thing. I mean, it may be that will happen, but I think it's a risk because you don't just need a high carbon price. You need certainty about the future. You know, these investments, they take 20, you know, you're building a storage facility, you want to be running it for 20, 30 years. You don't want to build it, you know, just, I mean, particularly at the storage, on the storage side, the investments are very long duration. So, which is why I think the only way in Europe you can get that kind of absolute certainty about the future is through regulation. If entities are regulated to store, then the future of storage becomes as predictable as the future of fossil fuel demand, which is depressingly quite predictable. So I think that's where I like the idea of a mandate rather than just relying on the price. The other issue, of course, with relying on the price is that you then have a risk premium in the investments because the investor is having to basically take a bet on what the future of the carbon price will be, and so they will then demand much higher cost of capital, and most of the cost of carbon capture and storage plants is actually the capital cost, and so anything which makes the capital cost higher, anything which sort of adds to the risk of the financial risk of the project, makes the whole project more expensive. Again, if it's a regular, the amount that fossil fuel companies need to pay for capital to address their sort of health and safety for example, is much lower than the amount they would demand for capital to build a CCS plant, because the CCS plant would be risky because they would see it as there's a risk that this plant might lose money if the carbon price goes down again, whereas for the health and safety investment, they say, well, we just have to do this because we want to keep producing. So we just there's no real risk in that investment. So I think this I think continuing to rely on the carbon price is a risky bet, and it's increasing the overall cost of the transition. But I mean, it's economically optimal.
I think I won't throw it all the way through this room. So.
And by the way, I'd love for the UK to join in that Net Zero Industry Act mechanism as well. Who knows, maybe it will.
I have just one thought to share. Don't expect any reply, but you may remember the 2020 goals of the European Commission in the previous phase. And when you look at the nitty-gritty details, the ETS was one of the main driver factors of the success of this policy. Now, if you look at the price of the ETS during that phase, it was all over the place. Very volatile, sometimes very high price, sometimes very low price. Yet the ETS outperformed. So in my view, I think what matters in the ETS is more the cap than the trade. Put it differently, the cap that decreases over time rather than the actual price of the allowance. This is just a thought. If you have some opinion, please share it.
The difficulty, and this is, if I may just chip, the difficulty is, as the cap declines to zero, the problem is that, cement producers and sort of people who are still affected by that cap, they have another option. They just leave. And then, of course, we get into discussions about CBAM and so on. But and we don't really want to. I mean, for the world, we don't want to give them that option. If you obligate them to store, particularly if you obligate them to store within the European Union's jurisdiction, then they don't have the option of leaving. They have to fix the problem. And so again, that's another way of the European Union more effectively internalizing the true impact of the fossil fuels we still use.
So one question I have: who in that model is then paying for the transport, for the capture, and for the?
Well, in the Net Zero Industry Act, yeah, the capture and transport is paid for by the capturer to avoid the ETS price. So that's the model that the European Commission has at the moment. Is that this obligation is only used to provide storage capacity. It's a temporary obligation. It's just sort of to get us through this problem that we're lacking storage capacity in the European Union. And that the idea is that the point source, the people like cement plants will capture and transport. My view would be a much more robust model would actually be to obligate entities that want to bring fossil fuels into the European Union, whether it's out of the ground or in through pipes, to store. And then they would pay for CO2. So interestingly, Norway/Equinor is less keen on this scenario, but I think it's perfectly, perfectly reasonable, which should be discussed. That if you want to bring fossil carbon into the European Union, you need to get rid of it. Not all of it straight away, but more and more and more of it over time. And that would create an actual market for CO2. So people would actually be out there buying CO2, paying for capture in order to store it. Which I think would be interestingly, that would actually create an incentive to keep high carbon industries in Europe, because we'd want to capture their CO2 in order to deliver this obligation. And that would be a really helpful thing for the world. Because unlike at the moment, where Europe has this tendency to push carbon industries away from it, which actually is a bad thing for the world because it means they get pushed out. There's a sort of pressure when investors are deciding where to put a cement plant, they don't put it in Europe because you have to pay for the CO2 and all that. But whereas, we want those plants to come to Europe with carbon capture, of course, because we want to make them safe.
Just briefly add or repeat something that you actually said before. We need to think about how to make this relevant for carbon dioxide removal as well. Yeah. So not only disposal. I don't know if a quota could work or something like that, so that a share of the CO2 needs to be biogenic or atmospheric. So I think that's something that we really need to keep in mind if we want to think about getting majorities also for these kinds of instruments, so making it CDR related.
Do you see a chance that on the G7 level there is any preparedness to create some sort of level playing field in that area?
Very difficult, because the modes of or how climate policy works are so different in the US and Europe. So I think in terms of CDR, it is really more about what you could do at G7 level is agreeing on a pledge, for example, like a public procurement pledge or something like that to create demand, or maybe net negative. It's really more agenda setting than having a level playing field on something like injection capacity or something that specific.
I mean, one thing, you mentioned this earlier, one thing the G7 could do is just start to report geological storage capacity and the actual geologically stored fraction. At the moment, we have just academic papers telling us how much storage there is out there. And that's nuts. I mean, fossil fuel companies have to submit their reserves estimates for audit, and the CEO loses their job if the reserves estimate turns out to be wrong. They should be equally required to provide storage estimates. And the CEO should lose his job or her job if their storage estimates are exaggerated. I mean, we're counting on this stuff. So why is there no audit requirement for storage capacity? Again, that's something the G7 could introduce very easily. And it wouldn't be expensive. That's just a requirement, because it's a requirement on the industry. They claim they know where this storage is. And yet it's all just, oh yeah, don't worry about it. We got plenty. Who's checked? Yeah.
Fair.
Yeah, thank you. Very interesting discussion this. I'm sure, we will manage this. My next question is more on a longer time scale, because this is an immediate problem we have now and we'll have to face for the next decade or so. But when we have all this CO2 on a ship or in a pipeline, or will it not then eventually become a commodity that we can use as a material to produce whatever? I mean, you can produce, my favorite project is some fish producer who makes proteins from CO2 eating hydrogen producing bacteria. Or is it the opposite? I can't remember. But there is no limit to what you can use CO2 to make if you just have it accessible in a dense format. Thank you.
Do you want to take that one?
Just to say that what we always hear is we sometimes hear from some sectors that we shouldn't store the CO2 permanently because we will need it in the future. That's the chemical sector saying we need it as a feedstock, so we shouldn't put it underground. So this perspective, if we think about CCS, CCU, and CDR in an integrated manner, we also hear these voices, and they are competing against those that want to push for CCS.
I mean, the amount of energy you need to put into a CO2 molecule to turn it into anything remotely useful is a lot. And I think we keep finding other ways we'd rather use that energy. So, I mean, I think turning CO2 into useful things only really makes sense if energy is free or negative cost. And although occasionally energy is negative cost in the UK and Europe at the moment, we, you know, over a long period, as soon as energy becomes really cheap, we come up with something else like generative AI to use it up. So, I mean, I'm not banking on energy being free anytime soon. And so I think CCU will always be a bit of a sideshow because of the energy requirement. It's always going to make more sense just to get rid of the energy, you know, synthetic aviation fuel, e-fuels, for the same amount of energy that is used to turn, so you have a certain amount of energy to capture the CO2 from the atmosphere. You then have to add 3 or 4 times that amount of energy to turn the CO2 into an alkane to make kerosene. Now, so therefore you could capture 3 or 4 times as much CO2 from the atmosphere and put it underground and then burn kerosene. Okay, you're still using fossil fuels, but you have a carbon negative activity. So which is better for the planet? Well, I would say very definitely the second one. Of course, for national security reasons, you might prefer the first one, but you know, then you need to be clear. No, I'm doing this for national security. I'm not doing this for the planet. The right thing to do with CO2 for the planet is stick it underground.
Perhaps there's one addition. There is also the opposite trend. There are projects trying to transform CO2 with as little energy input as possible into something as useless as possible and unreactive as possible, which is simply produced for the purpose of stowing it away with as little space needed as possible. And that seems to be a rather economic way of dealing with the problem. But perhaps one out of a number of ways. But I will hand over to the king or prince or whatever of CDR for last question.
Okay. Stop it. We talked a lot about the kinds of carbon removal and carbon management where you have a CO2 stream and then you stuff it underground. And I wanted to raise the other carbon removal methods, which, okay, might not be as fun to talk about, but other people might disagree on that. But particularly the kind of novel things that fall between the cracks a lot of the time, like enhanced rock weathering and biochar. There's a big question about how they might get to scale, but they're certainly being looked at by policymakers. They're in the EU carbon removal certification framework and so on. And maybe this is a question more for Felix and Kati. Kati, if you're still online. What do you think are the prospects in Europe for developing policies around those? Should it be some kind of obligation? Is it something a little bit more aligned to the way that policies are set up for landowners and land managers in the EU, like the Common Agricultural Policy, for instance? What might policy look like for those things?
So, Kati, are you still online? Can you hear us? And that's...
Yes, I'm here, but I missed the first part of the question. So if you can repeat, I'm sorry.
You can do it too.
Can you hear us now? Hi, Kati.
Yes, hi.
It was about the methods for, let's say, durable carbon removal, but often involve the land. And I'm thinking biochar and enhanced rock weathering, but there's also, I know, agroforestry and things like that. So things that are being looked at by policymakers, but don't involve a CO2 stream that you inject geologically underground. What do you see as a sensible way that policy might go in the European Union for developing those things?
Yes, so those solutions are definitely being discussed, and in this carbon dioxide removal framework of the EU, they have a big role. I don't know, one option, could it be that kind of the FOLU sector, so the agriculture and forestry sector, land use sector, that could be balanced. The emissions of that sector could be balanced with that kind of solutions, and then the permanent removals would balance the rest of the residual emissions. So that's maybe one way to that could be thought of.
Thanks, Felix. Thanks. Question went also to you.
Yeah, I think Kati already mentioned the key process. It's the carbon removal certification framework, where we will have methodologies for these methods. But I think there is also, I'm not an expert on these methods, but my sense is that there is a lack of understanding when it comes to MRV for these. So I think there really is a research need for understanding this better, and maybe also for if we talk about G7, I think there is some lack of coordination when it comes to CDR research projects. And I think when we strategically decide this project aims at improving the understanding of enhanced rock weathering, and the other is more working on biochar, I think there would be synergies if there is some strategic decision on who's dealing with what. And because you mentioned agriculture policy, I think that's very, very important, that we don't only come up with fancy new instruments, but mobilize the instruments that are already there, because it will be very hard to mobilize new funding for CDR in the coming years. And we really need to think about how can we mobilize the money that is already allocated and reallocate it to something that is relevant for CDR. And being in Brussels, that's of course agriculture policy, one of the biggest chunks there.
I just had, it was more a question actually. Does the CDR
removal certification?
Thank you for helping. The removal certification framework, does it specify appropriate uses of which types of CDR, or does it just talk about what they are?
Kati, I don't know if you want to respond to that.
No, I think it doesn't specify anything yet, and that's one of the criticisms that has been raised, that it's not very clear how we will use this framework. They are developing the methods how to certify different things, but we don't yet know how they will be used and for what.
I mean, what would be very powerful would be establish a principle of certain types of CDR for certain applications. So, fossil for fossil, I'd say, land for land is the sort of logical starting point. Only in exceptional circumstances would you want to mix land and fossil.
Thank you. Perhaps as a last point for you and the last challenge, perhaps I would like to paraphrase something from the policy brief that was actually presented today by Martin Johnson. I found that in a way very well put. There is still a serious disconnect between the perceived or implicit role of CDR and the readiness of technologies, the knowledge of potential impacts, as well as policy governance, legal and economic frameworks, and the public discourse needed to deliver a safe, effective, and socially acceptable CDR portfolio, and so on and so on. So I still, when I'm in these kinds of discussions, I still think we are running so far ahead of the reality of where we are in these technologies. Is that true or not? And if so, perhaps representing a funding agency, what would be the next thing? You said there will be little money for CDR. So if I had a number of euros, where to put it? What is the priority?
Maybe not in CDR. No, I was just about to say, I mean, what is different from other mitigation options? There is a huge gap in all technologies. We are not up to speed with hydrogen, with renewables. So this is not CDR specific. So I think we really need to think broader how we can integrate CDR systematically in the governance architecture of climate policy, and not singling it out as something special that has special needs. I think it is just one element of achieving net zero, and that's how we should frame it. I think that's more promising than singling it out too much.
I mean, oddly, I probably agree that with government, if it's your money you're talking about, I think money should be spent on CDR, but I don't see why it should be our money. I think that's where we need to focus efforts, is how do we create the policy frameworks that actually channels the money that's made when fossil fuels come out of the ground towards putting the CO2 back. And it can be done. I mean, the industry will fight tooth and nail. They did fight hard against Article 18, but the European Commission proved, first time perhaps ever, that it is possible to stand up to the fossil fuel industry. So stand up to them, regulate them. You're talking about a gap. I went to the CERAWeek meeting. I don't know if you know about CERAWeek. Anybody here been to CERAWeek? Okay, interesting test that. Okay, so I went for the first time. So 4 months after a COP, there's an anti-COP. It's like an anti-particle. And it happens in it happens in Houston, in the US, and it's basically a gathering of the oil and gas industry. Anyway, they invited me for the first time this year. They get sort of outside speakers to come and talk to them. And you're talking about a gap here, and in all of our assumptions about all the things that, you know, the policies that are going to happen. I mean, it's a different conversation there. And that's why I think that the only way of fixing this problem is to actually regulate that industry to fix it, because they have no intention of slowing down what they're doing. And the only way they will actually slow down what they're doing is when they actually start to run out of storage capacity to get rid of the CO2. And it starts to cost so much to produce it that nobody wants to buy their product anymore. That's the only way they won't produce their product is if nobody wants to buy it. They're very clear on that. And that's why, you know, if you want a different perspective, a real sort of reality check on climate policy, go to CERAWeek. It'll be depressing for you, but you know, we've got to realize there's another world out there that is working to a different timetable, and you know, it's only regulation will bring that. They don't respond to financial incentives because they have too much money. The only incentive they respond to is a license to operate.
So, Kati, you have the last word. No money into CDR research. That was the last request from the podium.
No. I didn't know we were talking about research money.
Leave it to regulating the oil industry. So, Kati, you have the last word.
Well, maybe just to raise, related to the earlier discussion on the CCUs, that EU has mandates for CCU products for e-fuels in the Renewable Energy Directive and the Refuel Aviation. So they don't have mandates for CDR. So, Myles, you have some work to do if you want to convince them on your opinion.
So isn't that a shame? But one day that will change, just because of logic. But hopefully it'll change sooner rather than later.
So thank you very much for a lively discussion. Last session today. Kati, thanks to Finland.